This lesson demonstrates how Java is used to load and display image files. You can find libraries of Java routines to load almost any file format, but built into standard Java is the capability of reading JPEGs, GIFs, and PNG files. Now, on a Windows system, the type of file is always determined by the letters following a period, but Java comes from the Unix world and doesn't use this tagging technique. You can actually name a file anything you like. You could name a JPEG file ending with .tif if you wished, and Java would look inside the file first before it came to any conclusions about the type of file. I'll be following the Windows suffix notation in this course, but I just thought you should know that Java is not that picky. This is the main line of an image display program. Loading an image file is a built-in feature of Java, but there are still a couple of tricks you need to know about. Here in the main method of the program, it allows you to specify the name of an image file you wish to load and display. Any of the three kinds of image files will do. They're all processed exactly the same. If you don't enter a name, the default name is earth.jpg. This is a photograph of Earth taken from space, and I'll be showing it to you in just a bit. The name of the image file is passed to the constructor. And this is the constructor. In the constructor, a call is made to image-from-disk, which is the method that loads an image file and converts it into an internal image object. No matter what the origin of an image, it's always stored as an image object in memory. An image can be loaded from disk, as we'll be doing here, or it can be created with graphics inside a program, and we'll be doing some of that later. You can actually draw on the face of an image in memory that you've loaded from disk, but all that comes later. Now, this statement creates a new canvas object and installs the image into it. That's in another file, and I'll be showing you that shortly. Anyway, the canvas object is added to the display in the same way that we've always added canvas objects to frames. This is the method that loads the image file from disk. An image file can be a large file and can take a while to load, and you can write a program that loads lots of image files, so there can be a timing problem. This call to the default toolkit method named getImage starts the image loading. It doesn't load the image, it creates an image object in memory and issues the command for the image data to be loaded into it. While that loading is going on, this program continues to run. The address of our new image object is added to a list inside the media tracker. Actually, the media tracker can have several of these lists, and each one is identified by a number, in this case, the number 1. The media tracker can follow the loading of any number of image items in any number of lists. You can query about the status of one list at a time, so you can load images in bunches and move on if you wish. In this example, there is only one image, so the media tracker doesn't have to do that much. If you're going to write a program that loads lots of images, you'll want to look into the documentation, looking at a bunch of different lists and letting most of them load in the background. Now, we're reading from a file, so some things could go wrong. One of the cruel actions of the media tracker is that it doesn't catch everything, but if you call wait for all, your program is halted right here until every image in every list is done. If you wind up with a zero-sized image that doesn't display anything, it'll probably mean the file was missing. If there's some other error in reading the file, this code will execute. Anyway, the address of the image object is returned to the caller. Now to take a look at the canvas that displays the image. As you can see, this is a very simple canvas. The constructor is passed an image file, which it stores in a local location. Then it uses the dimensions of the incoming image to size the canvas itself. The paint method is even simpler. It draws the image object at the location 0, 0. That's the upper left-hand corner of the window. The window is the same size as the image, so the result looks like this. There's the Earth. This is an image that's in public domain and is free for the taking. I found it on the NASA website. They have lots of images there, and they're all public domain. We've already paid for them. There is something interesting about this particular image. It's used again and again in television and movies, and it's easy to spot. You see this cloud formation here in the center? This is a very unique formation, and you can quickly spot it when it shows up. I've seen this same Earth with spaceships flying around it and lots of different shows. It was invaded in Independence Day and a few other movies. Okay, one other thing. I'm sure you noticed the keyword this in some of the method calls earlier dealing with images. Now here's the deal. The keyword this contains the address of the current object. That is, an object knows everybody's name but its own, so it uses the keyword this when it refers to itself. These methods require that the address of a calling object be passed to them, so that's why this is in those method calls. In the next few lessons, we'll be looking into some of the things that we can do with the loaded image files.